Welcome back to Mastering Next.js. In this module, we're going to be talking all about testing and error handling. So I'm going to give my overview and my philosophy for how I test my applications. Going to touch on the differences between all the different types of tests, unit integration, and more. Talk about kind of the current landscape of JavaScript testing. Do some actual examples with React Testing Library. Touch on snapshot testing, and then get into the error handling side of the module where we will talk about Sentry and talk about how you would do a custom error page. So the first thing I want to talk about is unit tests and integration tests. And one of my favorite tweets on this subject is from Zeit CEO, and it says, "Write tests, not too many, mostly integration." And it's correlated to this image which depicts kind of the importance of the different pieces of testing. And the best way that I can sum it up is when you're doing unit testing, you are testing one specific module or one piece of an application. It's on the most granular level. Once you start to get integration, now you're talking about how the components interact together and how that data flows throughout your application. Then, if you take it up a step even higher, end-to-end testing or acceptance tests, we're now testing actual browser behavior of how the user would interact with your application. So going out and physically clicking on things. Now each one of these has a different way you would implement them. For end-to-end tests, Cypress is one of the most popular. Integration and unit, we're going to be talking about Jest, and then you can do static checking with TypeScript, Flow, whatever you want to use. I think the underlying philosophy that I want to drive home and that you should think about is you want your tests to resemble how users actually use your application, because those will give you the most confidence and be the best return on investment for the time it takes you to write those tests. So you might hear people talk about you should strive for 100% unit test coverage in your applications. And while that is a great goal to shoot for, depending on the size of your company or the scope of the project that you're working on, it might not be the best return on investment to create some of those low-level tests. You might be better to do, a simple set of smoke tests that ensure that the main pieces of your application are working as expected. So maybe that's the login flow, maybe that's the payment flow. You want to make sure that you do those highest value, biggest return on investment tests first. And that's part of the reason why I think we've seen a really big shift in the JavaScript testing community over the years. There was a bit of churn of the different solutions that we used. It started out with a lot of things like Mocha and Chai and trying to figure out how we wanted to test the front end of our applications. Enzyme came along and really simplified how you could retrieve elements and made the API for actually writing your tests a lot more simple. But since then, I think we've kind of settled down and standardized on using Jest, which we'll be doing an example of for integration and unit tests. And that's the actual test runner for how we're going to execute our test. And then we've also started to standardize on using React Testing Library, which is essentially a set of helpful methods on top of Jest that allow you to easily retrieve elements from the DOM and provide a better way to test your components that's more aligned with the philosophy that I described earlier. And you can really start to see this adoption by the fact that React Testing Library is now included by default in Create React App, which the maintainers of React recommend for people just getting off the ground. And there's quite a few examples with Next.js as well. And that's really because it's just designed to pair well with React. Now, at the top level, there is a testing library, and then there's different implementations of that testing library with the same API for different programming languages or frameworks. So I've already got the boilerplate for my tests set up in this application. I'm going to quickly touch on what it takes to get a React Next.js app configured to run tests with Jest and React Testing Library. And thankfully, it's actually really simple. The first thing you would probably do would be to install the dependencies. So we're going to be using React Testing Library, Jest, Babel Jest, so that we can compile our code. And then Jest DOM is a set of essentially helper functions and matchers that will allow us to check specific things on the outputted DOM from when we've rendered our components in our test. So we're going to make use of some of these custom matchers in our test. So I would recommend installing that as well. So you have these dependencies installed. The next thing you need to do is configure your test runner to know that we're using Next. So by overriding our Babel RC file and saying that we're using the Next Babel preset, this will allow Jest to pick up and understand how to compile the code based on the configuration of our Next application. So we have our dependencies. It knows how to compile the code. Really, the only piece that's remaining is you have to have a script that invokes the starting of Jest. So when I run yarn test, it's going to run Jest behind the scenes. Jest is going to be able to intelligently realize which test files are in this directory, pick those up, and run them. So I can show an example of that right now before I dive into exactly what's happening in these tests. Awesome. So you can see it shows that 2 sweeps passed. I have 7 tests wrote that I'm going to talk about, and there's even 1 snapshot included as well. Now, in this application, I have a app file that I've overrode to provide some common layout between the entire application. So things like authentication, the chakra theme, the dark mode, a CSS reset, and then finally the component that's rendered underneath. And when we're testing our components, we need to replicate some of the functionality that happens in this app so that these things can be available when we're rendering out specific components. And to do that, we need to have a setup as part of running our test. And we can do that using just a simple utility file that will allow us to override how we're going to render these tests. So I'm taking render from React Testing Library, and I'm saying actually everything that we get rendered, we want to wrap in Chakra's theme and color mode provider so that all of these things are available and we don't have to duplicate those providers in every single test across your entire application. So we define our specific Chakra renderer. We say that we're going to override the render function that comes from React Testing Library and then re-export that one as the default render, as well as exporting everything else that you would normally get from React Testing Library so that we can have those available. Now there's 2 other things in here. We're importing all of those Jest DOM matchers so that we can use them. And then I'm shimming this mutation observer because I'm using React Hook form in this application, and one of the requirements to get the test working was to shim that out in our test. So depending on the application that you're writing, you may or may not need that, but I would recommend everything else inside of this file, especially when you're using Chakra. So this gets a wrapper around our tests so that we can run them and provide the correct values. Let's take a look at how I structure my tests and how you can query data from your components. So the first test I want to look at is for this bar card component. So let me pull that up over here on the right. And this is a very simple presentational component. It takes in a few different options about the bar and then basically just uses display properties from Chakra to render out this card component with that information. So I can actually pull this up over here on the right. This is the specific component we're looking at. It has the amount of deals, the name of the bar, and then the location as well as an image. So if there's multiple deals, it has an S at the end, and if there's only one deal, it just says one deal. That's one of the conditional pieces of logic that we're going to want to check, as well as making sure that all of these props that get passed in are correctly shown on the screen. So the way that Jest looks for test files by default is using this .spec.js notation. Now you can totally customize this to do whatever you want, but out of the box, this is what you're going to get for free. Now, the way I like to structure my tests is having a top-level describe block That's the name of the component. And then typically, if there's any setup on the component test that I'm going to need to do that's shared across multiple tests, I'll put that in a before each. So for example, we're going to talk about a few different tests in this file, and they all are going to be passing the same or slightly different props to the component. So I set up that object in the before each so that I can just spread it out in the render and not have to duplicate that code over multiple tests. So up here at the top, you'll see that I'm pulling render from that test utils file, which had the Chakra theme provider and color provider available for us, as well as all the other React testing methods. We import the bar card. We're going to set up some props that emulate this bar, name, address, deals, which we could fill out fully, but for the sake of this test, we don't need to know the specifics, and then an image URL. So let's look at this first test. We want to inspect that the name, address, and image get rendered as we would expect. So you'll see we call render, we pass in that component, and then we're able to destructure a couple different matchers or a couple different methods that we can use to query data. Now you're probably wondering, okay, what exactly are these? And luckily, React Testing Library has a nice little cheat sheet for the different ways that you can query data. Definitely the most common that I use would be get by text, because that is saying find me the text that's actually rendered out on the screen. If there isn't text, like for example, this image, we're going to pull by the alt text. This happens a lot of the time when you're not actually rendering anything to the screen that's visible text, but actually it's being passed on as another property or attribute on that component. You can also do label text, placeholder text, display value, like we said, alt text, title, role. All of these are the hierarchy of how you want to move down that tree of what's available, and then kind of the last ditch effort. If none of those query methods work, you can fall back to putting a data test ID attribute on that component, and then you're able to have access to all of the different ways to query that data. So you see we have get by, find by, query by, get all by. Each one of these has a different way that it matches data. Get by, you're basically saying, I know that this is going to be here. Find by is going to await to make sure that that information shows up. Query by, you are not sure that it's going to be there, which happens quite a bit for like error state or empty state. Then the all by matchers are essentially the same thing, but you could have multiple. So you might have multiple images that have, similar tags, or you might have multiple text that shows up. So that's kind of the extended matcher for those. So if we hop back over to our test, the two that we're utilizing here, get by text and get by alt text, we're pulling the name, address, and then we're using the alt text of the name on the image. And finally, we're expecting that these three properties are available and showing in the DOM. Now, if we were to put something bogus in here, you're going to see in the output that it can't find that match, and it's going to output the DOM that it's seeing. And you can take this and review it and see, where did I mess up? So I was looking for an alt text of the name of the bar, which is new bar. And you'll see up at the top, here's that alt text of new bar. So that's what it should be, but it's clearly not what we're putting in the test. So that's how you can verify that that's working as expected. The next test we can look at is how we want to check for a badge that has only one deal. So by default, the props that we set up here, there's only one object in this array. So there should be one deal as a badge in the DOM, and we want to make sure that that's not null, which this can be not null, or you can have a even more helpful way to say it's visible in the DOM. If there's multiple deals, then we can just extend the props and say now we want two objects. Again, you could fill these out, or you don't have to provide additional clarity on what's inside of these objects, because in the component, we're only checking for the length of this array. So we do that, and then we can check and say, okay, there should be 2 deals as a badge in the document. And again, it could be not to be null or to be visible. Somewhere inside of here, in here, we have all of the different matchers that we can use. A couple others that I've found pretty helpful would be to have attribute, as well as to be disabled. I've used quite a few times. So if I go back to these tests and rerun them now, they should pass that I fixed that change that we made. Okay, so that's bar card. That's a really simple example. That's just a basic presentational level component. We're wanting to check the visual output of some of those things that we've rendered. Another alternative to doing tests in this way would be to do a snapshot test. Now, in my opinion, snapshot tests have a lot of pros and cons. They are great for things like checking what error messages are, CSS in JS. If you're making a component library that's, the outputted structure of those components is paramount, they work very well there. Or other, smaller modular pieces. Where they don't work well is when you start to get these really large snapshots, which people then will have a tendency to kind of ignore. So what a snapshot looks like, if we were to take the render from this card and create a snapshot, what Jest does under the hood is it captures the output and it writes it to a file that has a .snap extension. Now this file gets saved, and usually you commit this as part of your pull review process, and it goes into Git, and then you would review these changes on a DOM specific level as part of that PR process, so you can see exactly what changed. Now this is great for certain things, but if this was a massive component, this snapshot would not be very helpful at all. And when that happens, you see that people start to just blindly ignore these or blindly accept them on PRs. So my only advice would be to use snapshot testing cautiously, because it has its pros and cons. For this test, I'm going to say that we probably shouldn't do it, because I think that the other tests do a better job of conveying that message here. So since I removed that snapshot, if I do yarn test -u, it's going to say update the snapshots, which in this case, it should just remove that snapshot that we're no longer using. So we can delete this and remove it from Git now that we're not using it. So snapshot tests can be very helpful, but please use them with caution, because more often than not, I would say a traditional test like this, especially for React and Next.js, is probably going to be better off. Plus, in this component, which is more of a unit test on a very small component scale, I would recommend going to larger page-based integration tests, because I find there's a better return on investment there. So let's take a look at the SignIn Flow and write a test for that. This is definitely a critical path for this application. We need to make sure that users are able to sign in. And as part of this, we want to test that full flow of putting in information, hitting click, and then ensuring that things go as expected. So let's close out of this test and pull up the sign-in file. Now we have talked about this file a little bit. What we're doing here is using our authentication hook. We are pulling off that sign-in method that we're using to communicate with Firebase. We pass in an email and password, and then based on that, we try to either reroute to deals, or if there's an error when talking with Firebase, we show that error on the screen. Now, in a traditional unit test, you might say, okay, well, we're not concerned about this auth file because it's a separate component. So let's mock that out and let's not test any of the internals of that component. Now, the thing I like about React Testing Library is it actually steers you closer towards the path of less mocking and encourages you not to mock that and to test the full flow here. So even though I'm testing this sign-in page here, I'm actually going to be jumping into this auth file and testing this full screen auth, which is then testing our form using React Hook form, and it's testing this auth content piece, which is capturing the values in those inputs, and then submitting that form when you click the button. Now, when that gets clicked, it passes that email and password back up and then handles it inside of this component. So let's jump over to the test. First off, you'll see that we have a same setup as the bar chart test with a top level describe, a before each where we're setting up some things that pertain to multiple tests and then different tests as we go down. Some differences here, we are doing some mocking. So in general, I try to mock as little as I can, but for the sake of not going too far out of bounds for an integration test, I am going to mock a few things in here, which would be the use auth hook as well as the next router. If I was doing a end-to-end test through Cypress, then I would actually be going through this whole flow and not mocking anything, because I would be simulating the way that a real user is interacting with our application through the browser. So first things first, I am mocking those two files that I'm importing, and I'm going to set up a couple variables here where I can put mock functions. So when we redirect router.push, I want to mock out that function so I can expect that it was called. Similarly, I want to do the same thing for SignIn. And since this is a promise, I want to say that it's going to resolve successfully and go to this then block. If there was an error here, then it would go to the catch block. So I also set up an email and password, which will be the information that is entered into those inputs. One thing I want to quickly touch on here is that I'm hard coding this information, but you could definitely use a library like Chance, which gives you random data as part of your tests. As long as you're not doing snapshot testing, that random data is going to give you a little bit more confidence in just simulating all different types of input that you might throw at your component. The only thing that I can recommend there is that just because you are using chance and random data in one place does not mean that you need to use it in every place. There's really a time and a place for that level of random input. Sometimes it's a little more helpful to have clearly defined bounds for what your input is, especially for like Boolean values. So next we latch onto that used router and we say that the push method should use this mocked out Jest function, and the auth hook is going to make that sign-in function available and then populate a user ID. So that's all the setup needed. Let's jump into our first test. After rendering the component, we can use those query methods to be able to pull items off by text and label text. So let's get the email address, the password, both of these inputs, and then finally the sign-in button, which has the text sign in available. So we have these three elements available as variables. Now let's fire some events on those variables. This fire event method, we have change and click and a bunch others. These are available through React Testing Library that allow us to simulate events. So we want to say for the email, fire a change event and pass it this object, which simulates what the browser would be doing. Similarly, the same thing for password. So pass it the email and the password that we had defined up top. And then finally, click on the sign in button. Now, I have this whole thing wrapped in this act because this is basically saying that there's going to be updates that happen due to the contents of this act and some kind of state changes. And by defining it inside of here, it makes sure that your tests behave as you would expect. And you're able to await these changes so that when you do an expect, you have the new state that has been populated. So we await this test, and now we're able to expect that sign-in has been called one time, and it was called with the email and the password that we typed into our inputs, which is perfect. That's what we want. And then finally, since we're going into the success case, we want to make sure that the router push was called and that it successfully routed to deals. Now, this is where it's up to you to kind of draw the lines on where you want to mock and not mock things. For me here, I'm going to assume that the React router works as expected. I don't need to test that implementation detail of that routing. I would save that for an integration or not an integration, an end-to-end test. So that's why I've chosen to mock that here. Now let's look at if there was an error from the API. So if there was an error, you would be in the catch block and you would show a toast error message. So to do that, we can say the sign-in method, this promise, rather than resolving, we want it to reject the value and provide some message. This message is what gets passed into the toast as the description, which will show down at the bottom. So again, we're going to fetch these values, type in information, but instead, this time we're putting in a bogus username. We're going to make sure that sign-in was called again with the correct information. But this time, since it's rejecting the value on sign-in, we're not going to get into the router push block. Instead, we're going to go to the catch block, and we can query for these error messages that should be on the screen and ensure that they're visible. So that's pretty straightforward. The final test in this file is if there's an error on the input fields if we don't provide some value. So after getting the sign-in button, we fire a click on the button, but instead, in a difference from the prior two tests, we're not going to simulate any events on those inputs. So we're leaving them completely blank. Now, after this is completed, we can expect that the text is available on the screen and visible for the email error and the password error, and that sign-in and the router push have not been called. Now, I think this part is important because there could be an edge case where errors did show up on the screen, but you didn't have the proper logic in place that would prevent the sign-in flow or the router push from being called. So generally, try to be as thorough as you can with those expects so that you have more confidence in your tests. Okay, so that's how you would set up tests for your application using React Testing Library. Let's transition to error handling. And to do that, I want to talk first about Sentry. Now, Sentry is a SaaS solution for exception monitoring, which has definitely saved me quite a few times and helped me catch bugs before it impacted a lot of users, before it made its way out to prod, even sometimes when testing in lower environments. So I would highly recommend some sort of exception monitoring solution as your projects get further along, whether it's a personal project or working for the company that you're at. You just don't know what can happen once these things get out in prod, and unless you're monitoring them and have alerting set up, I think you would be surprised at how often you run into errors. Now, Sentry has SDKs available for a ton of different languages and frameworks, JavaScript and React included. So it's pretty easy to just plug and play, but there are quite a few little edge cases and specifics around server-side rendering, because we not only have to catch errors on the server side, also on the client side, and then you can also have errors that occur when you're fetching initial props too. So because of that, I would recommend just pulling down one of the either simple examples, which I authored on Next.js's examples repo, or they have an even more complex example that gives you every single feature of Sentry that you could ever possibly want. I would argue that it's overkill for a lot of people, but check out the simple example. It'll get you off the ground at least. But what I'm most excited for, which should be out sometime soon, is the plugin architecture for Next.js. Now, this is already released, but it's in an experimental, unstable state, and you can find this under the packages folder in the Next.js repo. But they already have a Sentry plugin, which drastically simplifies the amount of code that you need to set up on your own to get Sentry working. So essentially how this will work is you would install this package, and then there's going to be a few different environment variables that you have to pass along. The DSN, which is like a unique identifier for your project. And then if you want to specify a specific release of your code inside of Sentry, you can do that as well. The nice thing about this is that it abstracts away all of that boilerplate and all of that complexity, and it just makes it really easy to get off the ground. So I think we're going to see the packages architecture really take off going into the future. Maybe by the time you watch this course, it might already be out there. So definitely check this out first before you move to the example section. But if there's an error in your application, what do your users see? And often you want to customize what that looks like. So if I go to the day drink application, which is in prod right now, and I put in some bogus URL, whether that's a 404 or a 500, I'm greeted with a not very helpful screen. Now, Next makes it really easy to override this error state and do whatever you want. You could log things to Sentry, you could log things to whatever your logging provider is, and you can completely customize the look and feel of what this page looks like. Now, to do that, we can override this page that's underscore error. So if you notice a common theme, all of these Next specific files are prefixed with underscore app, underscore document, underscore error. And if we run this locally, you'll see that now if I have a 400 or a 500, I'm actually going to catch that with this error page, and Next will show this instead. And I put in some, funny logic here that allows them to return home and also still shows the header so that they can navigate away. And the nice thing about this is they give you the full customization to opt out and do whatever you want on this page. So you might want to show something differently if it's a 404 than a 500. You have the ability to do that here. So if I load our application, everything's fine here, but now I go to this bogus URL, you'll see that I get a much, much better error screen. So the combination of Sentry for alerting you when there's errors, as well as customizing when they happen what you want to show, will provide a much better experience for your users. So with that wraps up this module. We've talked about the differences in testing, unit test, integration test, end-to-end test, acceptance test, kind of the differences, the pros and cons of each one. We've dived into my philosophy on testing, kind of the landscape of, JavaScript testing right now, and why I would recommend using Jest alongside React Testing Library. Went through a few examples, saw what that looks like in the real world, and then finally went into error handling, showed Sentry, talked about the Sentry plugin, and then showed what a custom error page looks like so that you can completely customize that experience for your users. So with that, thank you for tuning in and stay tuned for the next module. Cheers.